Hello, in this video we're going to look at our exponent laws. Now there are 4 laws that we're going to look at that will build the foundation of all of the questions that you will be required to ask or answer. Now the 4 laws are as follows: that when you're multiplying exponents, you add, when you are multiplying exponents of the same base, you add them over the same base. If you're dividing exponents with the same base, then you subtract the exponents. When raising to a power, we multiply the exponents. And if there are more than one bases and we are raising to the power, we distribute it. Okay, so that's distributing. So let us look at each one of these laws and examples. Okay. So the first law, where we multiplying, we add the bases. Let's look at these examples. So we have 2 to the power of 4 times 2 to the power of 3. So they're the same base and we're multiplying. So this is going to be equal to 2 to the power of 4 plus 3, which is 2 to the power of 7. If you would like to have a try at these questions before I actually answer them, feel free to pause the video, answer them, and then you can use this to mark it and see if you'd actually get it correct. Okay, so let's do the second one. So we have 2 bases over here, x and y. So just be careful that we only multiply and add over the same bases. So for x, we've got this one here has a 1. It's like an invisible 1. So it's 1. There's no power, it's 1. And then we've got 5, so it's plus 5. And then for the y, we've got 2 plus 3. So we've applied the law to each one of the bases individually. So that would be x to the power of 6, y to the power of 5. The next one, here we have 2. Now there's a power of 1 over there and a power of 4. So that is 1 plus 4. For the x, we have x to the power of 3 plus 1. And then we've just got the y to the power of 1 there. There's no other y in this little term over here. So that is all. So this is 2 to the power of 5, x to the power of 4, and y. Then this over here, we've got x, and there's 1 over there, and there's 1 over there. We've got y, and there's only 1 over there. We've got z, and there's only 1 over there. And we've got p, and there's only 1. So this here is x to the power of 2, y, z, p. Okay? We don't usually write to the powers of 1s because we'll just make our work look really ugly. So if it's to a power of 1, we just leave it with no exponent. Okay? Let us look at the next law. Okay, so this one here is when we are dividing, we are subtracting. So here we have 2 to the power of 8 divided by 2 to the power of 5. So that's 2 to the power of 8 minus 5, which is 2 to the power of 3. Over here we have a division sign. Now we've got different bases, so we're going to do each one separately. So we have 3. It's always what's in the numerator minus what's in the denominator. What's in the numerator minus what's in the denominator. And z, there's a 1 there, but there's nothing in the denominator. So we're kind of minusing 0, right? So this here is x to the power of 2, y to the power of 0, and z. And, well, the y to the power of 0 is 1. You'll see later. So that is just xz. In other words, the y's cancel out over here, leaving us with just x squared z. Here again, we have 4 divided by 2. So 4 you can write as 2 squared. That's 4, right? And in general, it helps us to break all of our numbers into prime bases. So the prime bases for 4, in other words, what prime numbers do we multiply to get 4 is 2 squared. And then we're going to minus 1 from the denominator. We have x squared in the numerator and minusing the 1 in the denominator. And then we have 1 with the y in the numerator, nothing to subtract in the denominator. So this here is just 2 to the power of 1, x to the power of 1, and y to the power of 1. Okay, so our second law says that if we are dividing, we are subtracting the ones over the same base. Okay, let's look at the next law. So the next law is saying that if we are raising to a power, we are multiplying the exponents. So here we have 2 cubed raised to the power of 5. So it's 2 3 times 5, which is 2 to the power of 15. Yeah, this one's interesting. Don't be afraid of fractions, okay? So this is 3, and now we're going to multiply it with a third. 3 times a third is simply just 1. So in other words, that's just 3. Okay, here's one with a variable in the exponent. It's the same law we're applying. So just remember, no matter what they give you, you apply the law that is underlining it. So this is 4, and then this here is x times 2, which is just 4 2x. Okay, let us look at the next one. So here we're saying is if there's stuff in a bracket, if there's more than one base and we're raising it to the power, we are distributing it. So let's do this. So here we are distributing this power of 3 to each term inside. So this is 2 to the power of 1 times 3 times x to the power of 2 times 3 times y to the power of 1 times 3. So this is just 2 cubed x to the power of 6, y to the power of 3. Okay, so this one here, again, we are distributing to each term. So this is 4x times 2 times 3, 1 times 2. So we're multiplying each thing by 2. And that's 2x times 3 to the power of 2. Okay, here's a quotient. Okay, so we're going to distribute everything to each thing. But we're going to leave that y in the denominator, but we're still going to distribute. So it's going to be 2 to the power of 4 times 2 times x to the power of 2, 1 times 2 over y to the power of 2 times 2. So can you see we've distributed it to each of the terms? So this is 2 to the power of 8 x squared over y to the power of 4. Okay, so those are the 4 exponent laws. And just remember, however complicated your questions get, you still need to apply the underlying laws that we've just spoken about. Let's look at some more definitions that you'll use when working with exponents. Okay, so the first thing, if we're writing something to the power of n, it's that thing times the same thing times the same thing times the same thing n times. So you already know, like 2 times 2 is 2 squared. 2 times 2 times 2 is 2 cubed, and so on and so forth, right? Here's a very important one, that anything to the power of 0 is 1. Okay, so like for example, 1 to the power of 0 is 1. 1,000 to the power of 0 is 1. A to the power of 0 is 1. So 2xy all to the power of 0 is 1. Anything to the power of 0 is 1. But be careful, it's only whatever the base of the exponent 0, that's 1. So for example, if it's 2x to the power of 0, then only the x is going to become 1. So the answer is 2. So watch out for these cases here where they try and trick you. Okay? Then we have that if we have a quotient in an exponent, what does it mean? So earlier we did see a third. So what does it mean? It means that the denominator is the root. So if it's n is in the denominator, we're taking the nth root, and then the m is the power. So for example, the square root of a, we can otherwise write as a, the power of a is 1, and the root, if written nothing, is 2. So a to the power of half is the same as a, the square root of a. And likewise, a, let's say, squared, the third root, the cube root, is a 2 over 3. That's a very important concept. Then we have negative exponents and how to deal with them. Normally the question requires that you answer the question with positive exponents. So if you have a negative exponent and if it's in the numerator, you just change its position to the denominator. Please pay attention. The actual sign of the base doesn't change. It's just the sign of the exponent that changes. Okay, again, if it's in the denominator, you just change its place to the numerator. The sign of the base stays the same. It's the sign of the exponent that changes. So please watch out for that. So an example is 2 to the power of, minus 1 is equal to a half. If we have 1 over x to the power of minus 1, this is just equal to x. We brought it to the numerator. See the sign of the base. Let's try and put a minus here. So we have minus 2x to the power of minus 1. Now, we're not going to change the sign. The overall of this thing is still minus. That does not change. What changes is the sign of that. The 2 will remain in the numerator. Why? Because the 2 has no negative exponent. So the 2 remains in the numerator and only the x moves to the denominator. And its exponent now becomes positive. Please, this is very important. Okay, so let us just go over what was our exponent laws. Okay, so what we've done now is the exponent laws. We've gone through each of the laws that we've got. That a to the power, when we multiply, we add the base, we add the exponents over the same base. When we divide, we subtract exponents over the same base. It's the numerator minus the denominator. When we are raising to the power, we multiply exponents and we distribute over many bases. Okay. And then we've done all of those lovely examples. And then further on, we've learned the new definitions of that's the definition of something to the power, to an exponent. Anything to the power of 0 is 1. When we have fractions, that's what it means in terms of exponents, and also how to deal with negative exponents. Okay, thank you so much for watching. Please add comments about what you'd like to see, the type of questions that challenge you, and watch out for our next video. We will do more complicated examples on exponents. Thank you. And don't forget to subscribe. Thanks. Bye.